Welcome to qnawire.
So here we have the graph of the position versus time function for the bicycler A and bicycler B. Here we know for part A, the two bicycles will have the same velocity at any time when the instantaneous slopes of their x versus t graphs are the same. So essentially, when the slope basically, which gives the instantaneous velocity, is the same. So if we were to draw that for A, the slope would cross like this, and this slope right here this line right here would be a parallel to line B. So we can say that velocity of A at t sub 1 would be equal to velocity of B at t sub 1. For B, we know we're trying to find the greater acceleration, and we can say that the acceleration of A is greater than the acceleration of B because the acceleration of B is going to be 0. Because the graph for A is concave upward, this means that there is a positive acceleration. So we can say graph of A is concave upwards. And so it has, again, a positive acceleration. The acceleration of B would actually equal 0 meters per second squared. And for C, we know that the bicycles are going to pass each other at the times when the two graphs cross, because at that point they would have the same position at that time. So we can say that the graph with the steepest slope is the fastest bicycle, and so is the one that is passing the other bicycle at that instant. So we can say that here B passes. We'll actually just call this 1. Call this 2. So at 1, bicycle B passes A. 2, bicycle A passes B. But again, at 1 and at 2, they are actually at that same position. For D, we know that bicycle B has the highest instantaneous velocity at all times until t sub 1. So until t sub 1, so we can say velocity of B is going to be greater than the velocity A, and this occurs from 0 to t sub 1. And then we can say that velocity of A will be greater than the velocity of B, and this occurs at t sub 1 to t to infinity. And so for part E, we want to see the average velocity. Here, the bicycles appear to have the same average velocity, because here, if the starting point of the graph for a particular bicycle is connected to the ending point with a straight line, the slope of that line is the average velocity. And so both appear to have that same slope for that average line. So here, because the average slope of A and the average slope of B are somewhat equal to each other, we can say that velocity of A average would be somewhat equal to the velocity of B average. That is the end of the solution. Thank you for watching.